Force and work. So this is just continuing on topic 5. It says when a force is applied to an object causing the object to move, then work is done on an object. So whenever we put force onto something and something moves, that's considered work, basically. Note that the force applied to the object must be greater than all other forces acting on the object in order to cause it to move or perform work. Just because energy is exerted does not mean that work is occurring. So is any work being done on this wall? So if we look back at the definition, when a force is applied to an object causing the object to move, that's work. If we're pushing on a wall, well, it's probably not going to move. I'm guessing that girl can't actually push a brick wall. So really there's no work being done on that wall. How do we calculate work? Well, it says the amount of work done on an object is measured in joules, and joules is basically a measurement of energy, I guess you could say. If you look at, I guess, some labels on food, you see calories. You've probably heard of calories before, and kilocalories. Those can be actually converted into joules. So it's just a type of energy that's sort of locked in whatever we're doing. So it says it can be determined by multiplying the force applied to the object, which is in newtons, by the distance that the object travels, and that needs to be in meters. So it's really important that you write this stuff down on your formula sheet, and then writing also what these units are, because they can sometimes trick you and put a question like the so many kilometers or so many kilojoules. So you really need to make sure that it's in joules, newtons, and meters for this calculation to work. Let's just take this over to a new, maybe we can do this. Oops. So let's try this out. Try some of these. So just to refresh ourselves, we have our formula here is W is equal to FD, and we can do number 1. So it says you exert a force of 25 newtons on your textbook while lifting it a height of 1.4 meters to put it on a shelf. How much work did you do on your textbook? So again, our formula is W, F, and D. I'm just going to write those there so that we can figure out what our question's giving us. It starts out and says that we exert a force of 25 newtons, so that's on the force, or the F. And you lift it 1.4 meters, so that's our distance. So our work is what we're trying to figure out. We just need to sub that in. So work is equal to force, which is 25, multiplied by 1.4 meters. So if we go 25 times 1.4, we get 35. And work is always measured in joules, so you should have a J there. If I can actually write it. Okay. So that's how you would do question 1. Question 2. It says if this, well, I guess before I even do that, we know it's going to be WFD, so let's put that there before we start. I'm just going to do that there as well. So it says if the steam from an engine does 102.5 joules, so that's our work, of work propelling an object a distance of 26 meters, so that's our distance, 26 meters. What force is exerted? So we're looking for F here. Just a note for you guys, like we can plug this in and solve for F, but what I always like to do for you guys is change this so that you don't have to really rearrange. So if I want to isolate F, it's going to be F is equal to W divided by D. So if we use that formula, we can calculate this. So 102.5 divided by 26, that gives us 33.94. That's a force, so it should be in newtons. If we look back at our question, just because I like to stay with my significant digits, this one has 2, this one has 4, so we're going to be dealing with, we want to round this, sorry, to 2. So this would actually be 3.9 newtons. Okay, so that is that. We paste this one again there. Let's do number 3. So number 3, again, we're using the same formula. As we read it, it says how much force, so they're telling us we're trying to figure out force, is required to perform 18 joules of work. On a cart over a distance of 3 meters. So again, we're using the formula F is equal to W divided by D. All right, just double check that I did that properly. And then we can plug in our information. So our work is 18 joules on the top divided by our distance, which is 3 meters. If we do that out, we do 18 divided by 3, we will get 6. So this is 6 newtons. Notice that in our question we have, this one was actually, and that's what I was going to change earlier. This was actually like that in the question. I'm not sure why it's not letting me write it. 18 joules. So this one is 3. The first one, 18.0, is 3. And 3.0 is 2 significant digits, which means our answer has to be to 2. So this is going to have to be 6.0 newtons to make sure that you're keeping those 2 significant digits. All right? So that's how you do those work calculations. They're not too hard, I don't think, pretty straightforward, but please let me know if you need anything. Again, this is the rearranged formula. This is the original formula, and if we're measuring for distance, then it would be W divided by F. Okay? So those are 3 that you can write on your formula sheet. They're just the ones, that's how they are rearranged for you, so you don't have to do the math there. Okay? So if we go back to here, I guess there's one more question. And we can do this one right here. So it says calculate the work done. So just to refresh that we have those formulas, we got W is equal to FD. We got D is equal to W divided by F. And we've got F is equal to W divided by D. Okay, so those are our 3 formulas. Let's try this one out on this question. The question says calculate the work done during a 7.5 seconds. That's a time. Interval to accelerate a 175 kilogram, that's a mass, motorcycle from rest to a speed of, so there's a speed there of 30 meters per second over a distance of 108 meters. So the question's asking us to calculate work. So work is what we're missing. Sorry, I'm writing that on the side. But we've got actually like a lot of information here, maybe too much. But we can use that information to I guess, figure out what we need. If we look at our formula for work, we need at least a force and a distance. And here we do have a distance, but we don't have a force. Okay, so this is one piece of information we have that we need. We still need a force. And to get that force, we're probably gonna have to use this information. So all of this extra information will help us to hopefully figure out the force. If I go back, let me see. If I go back to here, we've got this formula: acceleration is equal to F net over m. I think that is what we're gonna have to use. So I'm gonna write that here. F, or force net, is equal to ma. Is that what it is? Now I'm second guessing myself, sorry. Yeah, perfect. So our force is equal to mass times acceleration. We do have a mass here, we've got 175, but we don't have an acceleration. So there's actually another step that we need to do. We're gonna have to figure out the acceleration. So our acceleration is velocity divided by time, and we can do that here. So this is quite a few step question, but we got it. So our first step, I'm just gonna write step 1. We need to use A is equal to V over T. This is a great question because it uses like 3 different formulas. That's why having that formula sheet in front of you will help you to sort of pick which ones you need to use. So to figure out our acceleration, to then use it in this formula, to figure out our force, to then use that force in this formula. So there's 3 steps here. Let's do the first one. So we're gonna figure out our acceleration. We've got our velocity, which is 30 meters per second. And we've got our time, which is 7.5 seconds. So if we calculate that out on our calculator, we got 30 divided by 7.5. I get 4. So I get 4 meters per second squared. All right. So that's the first step. That's A. That's important. Now, step 2. We're going to use the formula F is equal to ma. Okay? Because we need to get force. We've got mass and acceleration now. So our force is equal to our mass, which I believe is 175 kilograms, yes? 175 kilograms. And that's multiplied by our acceleration, which we just found in the last question is 4, oops, don't know how that happened, 4 meters per second squared. Okay, so when we calculate that, 4 multiplied by our 175, I get 700. Yes. So 700 is newtons, because this is a force. So now we've got our force. Now we can use that piece of information to solve for work. So work is equal to force times distance. Our work our force we just found out to be 700 newtons, multiplied by our distance, which we had in the first part of the question, which is 108 meters. That's a little m. Okay. 700 multiplied by 108 gives me my work, which is 75,600. And work is in joules, okay? So that is our final answer here. And that's, again, an amazing question because it uses like several of the formulas that we used. So what's really important when you're doing these types of questions is setting up this table like I did. I'm writing down literally all the information they give us because that is going to help me figure out which formula I need to use and where I got to go to get to that. So our W is what we needed. We had a lot of information and we had 3 different steps. I guess I need to write step 3 here. Okay. We had 3 steps, 3 formulas that will get us to what we needed, which is the work. All right. So that is topic 5. If you have any questions about anything, please let me know. Try out the review assignment that goes along with this, and when you come back to class, you can pass that in. All right. Have a great one.